Today we will discuss tables of standard normal distribution. Before we start with tables of standard normal distribution, we can have a look upon the equation of standard normal distribution and also its important properties. The standard normal distribution is a case of normal distribution with the mean 0 and standard deviation 1. The equation of normal distribution is f of x equals 1 by sigma root 2 pi e raised to minus 1 by 2 into x minus mu by sigma whole square. In that equation, we put mu as 0 and sigma equal to 1. A standard normal random variable is usually denoted by z. Thus, a random variable z is z to follow standard normal distribution if its PDF is phi z equals 1 by root 2 pi e raised to minus z square by 2 and set between minus infinity and plus infinity. It is clearly a situation of normal distribution with mean 0 and standard deviation 1, and it is denoted by z follows n01. We know that a normal distribution will be symmetric about x equal to mu. In the case of standard normal distribution, since mu is 0, this frequency curve of standard normal distribution will be symmetric about z equals 0. We can have a look upon the PDF of standard normal distribution and its graph. See, this is the graph of standard normal distribution, the frequency curve of standard normal distribution. It's very clear that the frequency curve is symmetric about the line z equals 0. So with reference to this line z equals 0, the left and right sides are very identical. And we know that when the curve is symmetric about z equals 0, all these measures like mean, median, mode will coincide at 0. Now the height of the standard normal curve attained at 0 is 1 by root 2 pi. In the case of normal distribution, it is 1 by sigma root 2 pi. Since sigma is 1 here, the height will be 1 by root 2 pi, which is approximately 0.4. Now, we have a relation connecting the normal distribution and also standard normal distribution. That is given by if x follows n mu sigma square, then z equals x minus mu by sigma follows n01. That means normal distribution with mean, mu and variance sigma square can be transformed to standard normal variance distribution using the transformation z equals x minus mu by sigma. Now, when we back to the tables of standard normal distribution, we see that this equation of standard normal distribution doesn't have any parameters, unknown parameters. We have 1 by root 2 pi e raised to minus z square by 2. Now, these tables of standard normal distribution gives the probability of z between 0 and z, small z. That is probability of z between 0 and z. That is p of 0 less than or equal to z less than or equal to small z. By definition of the probability density function, that is, here we can see that a function f of x is said to be probability density function if it has two properties, that is, an f of x defined as x between a and b equals integral a to b f of x dx. That is the definition of a probability density function f of x. Using that definition of probability density function, this probability of z between 0 and z is actually integral 0 to z phi z dz. That is, here phi z is 1 by root 2 pi e raised to minus z square by 2 dz. That's why we have this probability of z between 0 and z as this integral 0 to z 1 by root 2 pi e raised to minus z square by 2 dz. Now, this integral represents the area of the function phi z occupied in between 0 and z. Now, area of this phi z between 0 and z because of a property of integral. That means if f of x is a function, integral a to b f of x dx gives area of the function f of x occupied between 0a and b. So in this case, this integral actually represents area of phi z between 0 and z. That's why the table is also entitled as area under standard normal curve. Area under standard normal curve. Now, the darkened sector represents this area between 0 and z. That is, probability of 0 to z is denoted by this shaded sector. From tables of standard normal distribution, we will get probability of this 0 to z, or area of the standard normal curve between 0 and z. We have different choices of z in the tables of standard normal distribution. That is, the value of z is combined using the columns and rows. That is 0, 0.0 and that second digit 0 from the column. So we have the least value of z as 0, 0.00, and the greatest value of z available in the table will be 3.59. That is 0.002 to 3.59. In some other tables, it will go up to 3.9. So in that case, that last greatest value of z available in the table will be 3.99. So for different choices of the z in between 0.00 and 3.59, probability of z between 0 and small z can be referred from these tables of area under standard normal curve. So we can have an example with value of z. Now if you choose z equals 1.85, now probability of z between 0.85 will be 0.4678. We can refer this value from tables, that is 1.8 the row and 0.05 the column. So 1.85 coincidence is the row 1.8 and column 0.05 coincidence is 0.4678. Thus, the probability of z between 0 and small z can be referred from the tables of area under standard normal curve. And here always the lower limit of z is fixed as 0. That's why we have a sector shaded with starting point at 0. Now, as we know, this standard normal curve is symmetric about z equals 0. The total area will be divided into two equal parts with reference to the line z equals 0. That is, minus infinity to 0, the area will be 0.5. 0 to infinity, the area will also 0.5. That is 0 to z and minus infinity 0. The sectors have area 0.5. Now we can look upon different values of z. That is p of z greater than or equal to 1.48. So in this case, the sector denoted by the interval z greater than or equal to 1.48 is displayed in the graph. So this is the position of 1.48, and here we consider z values greater than or equal to 1.48, which will appear in the right side of set. That's why we have shaded the sector corresponding to this right side of z equals 1.48. Now actually we require probability of z greater than or equal to 1.48, that is area of this sector shaded. But in tables we have recorded areas of z starting from 0. So in order to get the tail sector area, we consider the total area 0.5 and subtract the area 0 to 1.48 from the total area. The area from 0 to 1.48 can be obtained from tables. That's why we take the total right of 0 to infinity and also the area from 0 to 1.48. The total right of area is 0.5 and 0 to 1.48 area can be obtained from the tables, that is 0 to 1.48. 1.48 is 0.4306. 0.4306. That's why here 0.5 minus 0.4306, that is equal to 0.0694. Now if you take another interval of z lapping the left and right side of this z equal to 0, that is z equals minus 1.68 to 2.12. So we plot minus 1.68 in the left side of 0, 2.12 in the right side. So this shaded sector represents the probability interval set between minus 1.68 and 2.12. So in order to refer the area of this interval from the tables of standard normal distribution, we split the total area into with reference to the line z equals 0. That is P of z between minus 1.68 and 0 and z between 0 and 2.12. So the first interval represents the left side of z equals 0, and the second interval represents the right side of z equals 0. And we can also consider the symmetric property of standard normal curve. That is z between minus 1.68 and 0 will be same as z between 0 and 1.68, because this 1.68 is the image of minus 1.68, or they are equidistant points from z equals 0, and therefore the curve is symmetric. So area from z minus 1.68 to 0 will be same as area from 0 to 1.68, and this area we can refer from tables of standard normal distribution. The other interval directly you can refer from tables of standard normal distribution. So when we come to the tables, the values 1.68 and 2.12. So 1.68, you can see it is 1.68 is 0.434535, and next is 2.12. 2.12 will be 0.4830. So we take these values to the equation, we get it is 0.4535 and 0.4830. Therefore the total area will be 0.9365. Yes, here we consider this Z with different choices. Z has interval starting from 0, Z which contains a right tail sector, and again Z which contains left and right side. In this manner we can also consider sectors exactly in the left side of this Z equals 0. There we will have to take an equivalent sector. We have to shift an equivalent sector to the right side and again refer to the tables of standard normal distribution. Now we have considered all these cases with the help of standard normal distribution, that is the normal distribution with z mean 0 and variance 1. But there are situations where we have normal distribution with the mean 0 and mean not 0 and standard deviation not 1, that is n mu sigma square. In those cases, we have to transform that normal distribution to standard normal distribution with the help of this transformation relation. That is, if x follows n mu sigma square, then z equals x minus mu by sigma follows n01. So this transformation can be used to obtain this equivalent limits of standard normal random variable for these intervals of normal random variable where mean is not 0 and standard deviation not 1. So this is about the tables of standard normal distribution. Using these tables of standard normal distribution, we can refer these probabilities of z within various intervals.